Okay, almost ready. So, I want to start the day by asking you just a very, very simple refresher back in junior high. Okay, I want you to multiply these two fractions, 2/3 times 4/7. Do that right now. 2/3 times 4/7. Sasha, what'd you come up with, dude? Huh? So, how do we multiply fractions? Again, what's the deal? If you're multiplying two fractions, what do? You multiply straight across. What's 4 times 2? Hey, very good. Bottom one, what we get? Yeah, 8/21. Okay? Now, can we reduce or simplify that fraction anymore? No. How do you know that that fraction is in what's called simplest form? Its most simple form. How do you know? Because there are no common factors between the 8 and between the 21, right? And we can see that before we even multiplied. A 2 and a 7, I can't simplify that. 2/3, can't simplify that. 4/3. All of these numbers are sort of relatively prime to each other, so there's nothing we can do. All right, I have a different problem for you, and I'd like you to divide these, but it's going to work the same way, okay? I want you to divide these fractions here. And I'm going to give you this problem. I'm going to give you 2/5 divided by 3/7. 2/5 divided by 3/7. Go ahead and try and figure that one out. Division problem now. Okay, let's review. We got 2/5 divided by 3/7. I've seen 3 different answers as I'm walking around the room. So let's see if we can come up with the way that we do this. Now, remember, if I am dividing two fractions, what is the process for dividing two fractions? Yeah, we got Molly?
Don't you flip the right fraction?
Yes, we take the, and when we say flip, what do you mean by flip? We take the reciprocal. Very good. So I'm going to take 2/5 and multiply it by what? By 7/3. Good. And then I'm going to multiply straight across, just like I did before. So 2 times 7, what's that give me? 14. The 3 times 5 gives me what? 15. Now, is this fraction in simplest form? How do you know it's in simplest form? This down. So we are going together, we're going to multiply these two rational expressions. I'm going to give you 3x to the 4th power divided by 4x to the 3rd power. And we're going to multiply that by 2x squared, all divided by 5x to the 3rd. All right? Now, there's 2 ways that we could do this, right? And the first, what we're going to do is we're going to treat it just like we did before. We're going to multiply two fractions straight across, all right? Now, you have to remember, when you're multiplying, like, say, x to the 5th times x to the 4th, what is the general rule? If I have my bases, and they are the same, and I am multiplying these two together, what do I do with the exponents? We add them together, okay? I want to keep that in mind. So you guys tell me, what would 3x to the 4th times 2x squared, what would that have to be? Well, let's take the numbers first. What would the 3 times 2 be? That would give us a 6, okay? Now I have an x to the 4th power, and I have an x to the squared power, or x squared. I am multiplying the bases. What do I do with their exponents? Add them. So what would I get? Yeah, so 6x to the 6th. Very good. I'm going to divide that by, on the bottom. Give me the 4 times the 5. What's that give me? That gives me 20. Good. Now I have an x to the 3rd times an x to the 3rd. What would that be? X to the 6th. Very good. All right, now I need to take a look at my... Yeah, there's a lot that I can do here, all right? There's some more that I can do. First of all, do you see any fractions that represent a 1? Yes. Do you see that x to the 6th divided by x to the 6th is actually a value of 1? Do you see how I highlighted it and then put a 1 over it? Because x to the 6th over x to the 6th makes a expression equal to 1 because we're dividing the same two things, right? Any number divided by itself is always going to be 1 because there's only one thing to divide out. So that gives us what? 6/20. Very good. Because we don't need to put the 1s in there because we know anything times 1 is still itself. So 6/20. Can that be simplified any further? Yes, it can, right? 3/10. And our answer is now in simple. All right. This problem is a little bit more challenging. We have more difficult rational expressions that we have to deal with. There's more stuff going on, all right? And the way I like to look at this, when I do these particular problems, first I identify, okay, I'm multiplying this rational expression on the left and this rational expression on the right. Do you guys see the two different rational expressions? You guys see that? Hello? Okay, good. Then what I do is I break this up into like little parts, and I say, okay, this is the top left piece. Top left. You guys get that part? Right? Okay. This is the bottom left piece. Yeah? Okay, this is the top right piece here. Yeah? And this is the bottom right piece here. You guys see all those things? So I really have 4 separate pieces, right? You guys cool with that part? And each of them are in their certain spots, and I'm multiplying these together. Right? So here's what I want to do first. All right? I'm gonna multiply, or actually what I'm gonna do first is I'm gonna factor everything. I'm gonna factor all parts. And what I mean by all the parts, I mean the top left part, the top right part, the bottom left part, and the bottom right part. So you can kind of think of it like this, right? I'm going to factor all of these. So let's start with the top left. Is that piece factored? Yeah, it sure is, right? So if it's factored, I'm just going to leave it alone. Then I'm going to go to the top right. How do I factor 2x squared minus 4x? No, not a diamond problem. What can I pull out of a 2x squared minus a 4x? I can take a 2x out, right? And what does that leave me with? X minus 2. Very good, Kyle. Nice job. Okay, then I'm going to go to the bottom right, the pink one. The bottom right. Is that already factored? Yeah, I could write it as 7. You know, I can do times x if I wanted to, times x if I wanted to. I could do that, right? And then lastly, the hardest one, I have 5x squared minus 6x minus 8. Yeah, that's going to be a diamond problem. So for that one, I'm going to come over here and write down as 5x squared minus 6x minus 8. Now, what's my leading coefficient? A 5. So in this particular case, since I can't factor out the greatest common factor, remember we have to do 5 times negative 8. What's that going to give us? Yeah. So x squared minus 6x minus 40. Great. Then we do our diamond problem. What number goes in the top? Good. What number in the bottom? Negative 6. Okay, can we think of 2 numbers that will make this work? 40. What are the factors if I could do 20 and 2? Can I make a 6 out of a 20 and a 2? No. Give me something else. 40. What makes 10 and 4? Ooh, a 10 and a 4. Can I create a negative 6 somehow from a 10 and a 4? If which one's negative? The 10 has to be negative, right? Because negative 10 and 4 gives me negative 6. Okay, great. Now I can rewrite and split my middle term as 5x squared minus 10x plus 4x minus 8. Awesome. Very good work. Very good. I'm loving that you remember how to do this. So what can I pull out of the 5x squared minus 10x? And what does that leave me with? X minus 2. Great. So what am I looking for in the other expression? Good. What can I pull out? A 4. What will that leave me with? Awesome. Are those the same? Great. So we're totally stoked. And we get an x minus 2. And then what's the leftover piece that we have? 5x plus a 4. Yes. This is a process for sure. Great. Now I'm gonna put that right down here. That gives me 5x plus 4 and x minus 2. So it's very, very important that we remember how to factor this process. That's the hardest problem that I could ever possibly give you. Okay? So number 1, we factored all the parts. Okay? Number 2, what are we going to do next for our process here? Yeah, we're going to cancel out factors of 1. I heard there's a train in the room. Like, we're going to cancel out factors of 1. Does anybody see a factor of 1 anywhere? Yes, what do you see? X minus 2. Yes, the whole expression x minus 2. and the whole expression x minus 2, those create a factor of 1. Yeah, question. Oh, what's another factor of 1 you see? Which one? Yeah. I could choose this one, and I can choose this one, correct? And together those create a ratio of 1, correct? X over x. Is there anything else that can cancel out?
You cancel out the top left x and the bottom right x.
Oh, this x over here?
Yes.
And this x over here?
Yeah.
Yeah, so I can cancel that one with that one, right? All right, great. Is there anything else that can cancel out? No. Okay, now I have left over with, let's scan the top. What do I have left on the numerator? Just a 1? I see something else. I see a 2 left over on the numerator, don't you? Isn't it right there? Oh, I'm sorry. Yeah, the entire numerator when I multiply. Okay, the entire denominator. What do I have left with? 7? 5x plus 4 parentheses. And is there anything else? All right. Here's what I want you to do. I want you and your partner. Okay, I want one of you to take the expression on the left, and I want you to factor all the parts. And I want one of you to take the expression on the right and factor all the parts. And then talk to each other, okay? And then from there, we'll then have a seat. Here we go. All right, what I'd like to do is, let's look at the top left piece. We're going to scaffold this for you. We're going to do the top left piece. 4x, who can factor 4x for me? What's it going to be? Yeah, 2 times 2 times x, that's fine, okay. How about the bottom left piece, this blue piece I have here? Did anybody factor that? Yeah, what did you have to do? You did a diamond problem, very good. What number goes in the top? What number goes in the bottom? And what 2 numbers make this work? Negative. Can someone explain why the -4 and the 3 work? What's the point of that? Yes, thank you, Anthony. He says -4 times 3 is -12. And simultaneously, a -4 plus a positive 3 is -1. So what do I do with this information? X minus 4 times x plus 3. That's our product of 2 binomials, right? Multiply that by. Now, who can factor the top right, this piece over here in green? X minus 4. Somebody besides Cody. X minus 4. How does that factor? Just x minus 4. Very good. That's all it is. It's already factored. There's nothing, there are no common factors of a 1 and a 4, so we're good to go. And then what about this last piece down here, this 2? How do I factor that? 2. Okay, so in our process, have we done step 1? Have we factored all of the parts? Good. After step 1, we move on to step 2. Step 2 is to do what? Cancel out all the factors of 1. Does anybody see a factor of 1 here? Kyle, what do you see, buddy? Yes, this whole x minus 4 and this whole x minus 4. That's a ratio of 1, right?
What about the 2 and the 2?
Ooh, very good. What about the 2 and the 2? Get rid of those as well, because they make a fraction of 1. Now, anything else cancel? No. So then we do the last stage, which we call the cleanup stage. And what is left on the numerator? 2x over x plus 3. Now, am I allowed to cancel this x here and this x here? Yes or no? No, why not? One I'm adding on the bottom and one I'm multiplying on the top. So my answer then must be this, and it's guaranteed. Okay, last one. It would be great if you and your partner, if one of you decided to take the left expression and the other took the right expression, and you follow the process of factoring everything, and then finally canceling everything, and then finally cleaning up everything.